All right, we are in chapter 3, section 3. Let's begin with some warm-ups. It says, perform the indicated operation. Assume all variables are positive. Here's sort of a review of what we did last section. When these are exactly the same, you can subtract the coefficients in front of them. So 9 minus 2 is 7, and the variable with the exponent does not change. Here, let's see, what can I do? I can work with the numbers first. 28 divided by 4 is 7, and then I get x to the first power minus 1/5. So that is 7x to the 4/5. Still warming up. Let a function, this right here is what we call function notation. Let a function, f of x it's called, or a function evaluated at x, be equal to 3x minus 5. G of x, or a function g evaluated at x, is 2x squared minus 7. So first we're going to evaluate that function f at negative 6. So f evaluated at negative 6 means that I replace the x with negative 6. So negative 18 plus 5 is negative 13. This next one, I'm evaluating the function g at negative 4. So instead of an x, I write negative 4. Negative 4 squared is 16. 3 times 16 minus 7 is 25. Right, getting into our actual material. Operations and functions. So let f, the function f, and the function g be any two functions. A new function h can be defined by performing any of the four basic operations on f and g. So I can add a new function h of g is equal to f of x. A new function h of x is equal to f of x plus g of x. So I just take, if these are my functions, I'm just going to take f of x plus g of x, collect like terms, and I'm done. Subtraction's the same. H of x equals f of x minus g of x. I take my function f of x and subtract my function g of x. F of x minus g of x. Collect like terms, and there we go. Multiplication. Exactly what it says. F of x times g of x. Distribution. And division, okay? F of x divided by g of x. The domain of h, now reminder, I've told you this before, but domain is your input or your x values, okay? So the domain of h consists of the x values that are in the domains of both f and g. So I can look at the domain of f and the domain of e. What am I allowed to input to f, and what am I allowed to input to g? Additionally, the domain of the quotient does not include the x values for which g of x equals 0. Okay, right there. That refers to the domain of the quotient does not refer to the x values for which g of x equals 0. So right there, okay? This right here would say x cannot equal 2, negative 2, which would make that a 0. If I continue reading at the bottom here, we talk about power functions. Those are just exponents, remember? So far you've studied several types of functions, including linear functions, quadratic functions, and polynomial functions of higher degree. Another common type of function is a power function, which has the form y equals a times b to the x, where a is a real number and b is a rational number, and x is a variable. All right, let's try to do some of these functions. We're going to add and subtract first. So let f of x equals 4x to the half and g of x equals negative 9x to the half. Now these are just functions. It's just an input-output thing. So let's do f of x plus g of x. So I have 4x to the half plus negative 9x to the half. Okay, collect like terms here. I've got a positive 4 and a negative 9. So negative 5x to the half is your answer. It really is that simple. F of x minus g of x, 4x to the half, minus a negative 9x to the half, 13x to the half. Now, what are the domains of f plus g and f minus g? So the functions f and g each have the same domain. All non-negative real numbers. So that just means, like, what can I plug in or input for x? Okay? What can I plug in or input for x? Anything positive and real. Okay, when it's x to the half, that means it's the square root of x. No negatives. Right? All right, multiplying. So I've got two new functions, f of x equals 6x and g of x equals x to the 3/4. So first let's multiply. F of x times g of x is 6x times x to the 3/4. We're multiplying, which means I add my exponents. 7/4. Okay, dividing. I'm dividing, that means I subtract my exponents. Cool. Now let's look at these. The next slide is going to ask me about domain for those variables. Okay, for this one, it'd be all real numbers. That's my symbol for all real numbers. And for this one, I can't have all real numbers. This would be the same non-negative real numbers. I can't use that symbol, sorry. That's all real numbers. So non-negative real numbers. So the domain, well, let's move to the next page. So the domain of f times g consists of all non-negative real numbers. Now, f over g, that would be all positive real numbers. And x cannot equal 0. Cool? Okay, example 3. For a white rhino, heart rate R in beats per minute and lifespan S in minutes are related to body mass M in kilograms by these functions. Here I have heart rate and lifespan, both in minutes. So first we're going to find R of M times S of M. So 241 times M to the negative 0.25 times 6 times 10 to the 6th times m to the 0.2. So I can go ahead and multiply those whole numbers. I'm going to multiply these, and I actually get, keeping it in exponential form because it's a lot of zeros, 1.446 times 10 to the 9th. And then my variables, I'm multiplying, so I add them. Negative 0.25 plus 0.2. That gives me a final answer of 1.446 times 10 to the 9th times m to the 0.05 negative. Okay, it says to interpret R of m times S of m. Well, if I'm multiplying heart rate times lifespan, that would actually give me a crazy total number of heartbeats over its its entire lifetime. Crazy. All right, let's practice a few. So our guided practice. I have two new functions. I'm going to add them. Okay, I have the same variable and exponent, so I just add the coefficients, and I get 5x to the 2/3. Subtraction minus, collect like terms, I actually get negative 9x to the 2/3. Domain. So here, these are odd roots. It's 2/3, that means it's the third root of anything squared. So here I can say all real numbers. I can have negatives and positives. And here, same deal, all real numbers. Okay, multiplication, 3x times x to the 1/5. Multiply the coefficients, add the exponents. I'm going to change that to 5 over 5. That gives me 6/5. And division. So I subtract the exponents. This again would change to 5/5. And then I get 3x to the 4/5. Okay, my domain here. For this one, it's easy. All real numbers again. Here, all real numbers, except remember that denominator cannot equal 0. Use the result of example 3 to find a white rhino's number of heartbeats over its lifetime of its body if its mass is 1.7 times 10 to the 5th. Go back and find that equation. What's the mass? So this is m to the 0.2 times 241 m to the negative 0.25. Okay, if I multiply those coefficients, I actually get 7.92 times 10 to the 8th m to the negative 0. Oh, wait. My bad. Let's erase all of this. I messed up. And you guys can see that, which is totally fine. I'm using the result from example 3. We got as our answer 1.446 times 10 to the 9th m to the negative 0.05. So what I'm actually going to do is substitute 1.7 times 10 to the 5th to the negative 0.05. So I want to make sure m is in kilograms. Cool, I went back and looked at the problem. M is measured in kilograms. So I multiply all that out. Using my handy-dandy calculator, I actually get 7.92 times 10 to the 8th heartbeats. Alrighty, we're going to stop there for now.